This is some code from your book that does conversion into another base. The example does 93 in decimal to 135 in octal. And if you want to convince yourself that they're the same, in base 8, your digits are times 8 to the 0, 8 to the 1, and 8 squared. So a 1 times 8 squared plus a 3 times 8 plus a 5 times a 1 gives you 64 here, plus this is 24 plus 5. And you can convince yourself that that is indeed 93. So we're going to trace the execution of this change of bases. And before we do that, I'm going to write the line number in front of every line of code so that I can refer to it later. Okay, now we're going to circle all of the variables. So anything that has something written to it at any point in the code, I'm going to draw a circle around it. Alright, so I think I've identified the variables in this code, and in order to trace the execution, I want to keep track of the state of this program. The state of the program is the value of all of the data and the program counter, really, the line number. So I'm going to create a little table that I will fill in to keep track of those things. Alright, so I'm going to begin filling the columns in. The first column I'm going to use for the line number. Then I'm going to have the new base, the decimal number, and I'm too lazy to spell everything out, so I'm just using shorthand, the remainder, and then the last column is going to be our answer. In order to trace the execution, I'm going to keep track of the line numbers that execute, so I'm going to draw a little grid in here. All right, so I've got a table. If I was doing this normally, I would be using a sheet of lined notebook paper or graph paper. I think I'm ready to trace through this. So what I'm going to do is every time we hit a line of code and have to think about it, I'm going to write the line number down. We start with line 1, for example. Now all of the data, if we know what its value is, I'm going to put it in the corresponding cell. So initially we don't know what anything is. So I'm going to use a question mark. And this is the best that I can write a question mark. The answer we actually know at this point in time. The answer starts off as the empty string, and I'm going to indicate the empty string by a pair of empty quote marks. As we move through to the next line of code, in line 2, we read in the new base, and the user types in 8. Everything else retains the same value it had before. So if I wanted to be complete, I could write it down. In practice, often I wouldn't write it down in every single line, but for now I'm going to do that just for the sake of completeness. Line 3 produces no output. Line 4 reads in decimal number. What I'm going to do is I'm going to circle the values that change when a given line is executed to make it easier to spot that. Line 5 sets quotient to 1. Line 6 is the beginning of a loop. It checks whether quotient is 0. So here we can see that quotient does not equal 0. I'm going to indicate that out here. Line 7 sets the quotient to the decimal number divided by the base. We have an 11. Line 8 sets the remainder to decimal number. This operation calculates the remainder. Line 9 adds the remainder to the left of our answer. Line 10 sets decimal number to quotient. The next line that we execute is going to be 6 again, and 6 checks whether quotient is 0. Since 11 does not equal 0, we're going to continue. Line 7 sets quotient to decimal number, which is 11, divided by 8, which is a 1, with 3 left. Line 8 gets the remainder. Line 9 makes the remainder the next digit in the answer. Moving from right to left. Line 10 sets decimal number to quotient. We're in a loop, so we're going to go back to line 6, and we're going to check quotient. So 1 does not equal 0. So we're going to continue now with line 7. Line 7 sets quotient to decimal number div base. Decimal number is 1. So we have a remainder of 1. And quotient is 0. Line 8 sets the remainder. Line 9 adds it to the answer. Line 10 sets decimal number to quotient. Line 6 is executed, and when we go to line 6, we find that the condition is not true. Quotient actually equals 0, which means we're going to branch down out of the loop to line 11. And we're going to print the answer is, and then in line 12, we're going to print the thing that's currently stored in answer, which is 135. So this is tracing through the code. We can see exactly how many operations happened. One thing that I'd like to point out is that we actually executed line 6 more times than we went through the loop. So you can see here we went through the body of the loop 1, 2, 3 times, but we executed line 6 1, 2, 3, 4 times. That's a general pattern in code. Whenever you do a loop, you always have to check your condition before you can branch out. So your condition generally gets checked one more time than the body of your loop executes. We saw that this produced the correct results, and if you keep track of your trace your execution like this, it's very easy. You go through it by hand, and you can step through your program to make sure that it does the same thing. And you can also work backwards to maybe spot some mistakes in your, as you saw, I might have done once or twice while stepping through this. All right, so this is my bookkeeping strategy. You don't have to use it, but you might find when going through problem sets or when trying to make sure that you can walk through the code yourself, this is a good way to organize the process.